Digital fluoroscopy is similar to conventional fluoroscopy in looks, but there are some differences that you should be aware of as a radiographer. This video will review those differences and other basic concepts related to digital fluoroscopic equipment. There are many advantages of digital fluoroscopy over conventional fluoroscopy, starting with post-processing capabilities. Post-processing allows for a reduction in noise, resulting in a high signal-to-noise ratio when compared to conventional fluoroscopy. Contrast is an issue when imaging soft tissues, such as the case with bowel and vessels. Contrast enhancement, a post-processing feature, allows for better visualization of low subject contrast anatomy. High detective quantum efficiency, or DQE, refers to the detector's sensitivity to photons. Other advantages of digital fluoroscopy include a wide dynamic range, decreased distortion, and the rectangular shape of the field of view when compared to the round field of view of the image intensifier. This allows for visualizing anatomy that may have been hiding in the corners. In a digital fluoroscopy suite, you will notice at least two mounted monitors. Each of the two viewing monitors has a function. The right monitor is used to view subtracted images if they are being used, or more often it is used to view hold or saved images. The left monitor is used to display the live image or last image acquired when fluoroscopy is not active. Whether a digital fluoroscopy suite or a C-arm, two monitors will be available for viewing of the images. The dynamic flat panel detectors, or FPD, replace the large overhead image intensifiers of conventional fluoroscopic systems. These flat panel detectors offer a larger matrix size as well as a larger pixel size. Operators can zoom in to see anatomy which is similar to the magnification mode in conventional fluoroscopy. There are two types of flat panel detectors, indirect and direct detectors. DFPs can function with continuous or pulsed fluoroscopy. You are already aware that pulse fluoroscopy is individual images taken with a break or space of time in between. This means the patient dose is decreased, but the video output appears to be continuous, while continuous fluoroscopy allows for constant exposure at lower MA settings. In this visual comparison, we see the continuous images being taken here using low MA settings. With pulsed fluoroscopy, there is time between each exposure. The time is small enough that our eye does not detect when viewing the screen. You need to be aware that both can lead to high patient dosages if not carefully monitored. Restriction of field size and the use of intermittent fluoroscopy is important to limit patient radiation exposure. A charged couple device, or CCD, is a solid-state device that converts visible light to electrons. Essentially, it is a microchip that is a type of video camera connected to the output phosphor of the image intensifier. It is only 1 inch long, and the CCD has many advantages including their small size, high spatial resolution, high signal-to-noise ratio, better contrast resolution, high detective quantum efficiency, which is a fancy term for being highly sensitive to light, which leads to lower patient dose. There is no spatial distortion, and the response to radiation is linear, making it easier to be electronically manipulated. One of the manipulations made easier with CCDs is digital subtraction. Temporal subtraction is the most common type of digital subtraction. The basic premise of subtraction technology is that an image of a body part is obtained and the computer inverts that image, so white becomes black and black becomes white. The computer overlays the inverted image onto the original image. The values cancel each other out, so you're just left with a flat gray-looking image. When contrast is introduced into the field, the contrast is clearly seen because this information has not been canceled out or subtracted out of the image because it wasn't in the original image. In this example, we see the overlying structures making the contrast difficult to see, but in the subtracted image we can clearly see the contrast. Notice the gray background in the subtracted image. Dual energy subtraction is a digital process feature that obtains two images with different contrast levels, one high contrast with many black and white values, and one with low contrast containing lots of gray values. This is accomplished by applying two different kVp values, one with high kV and one with low kV. This is often used to image the lungs, and the rib bones are subtracted out of the image with this dual energy or dual kVp subtraction technique. In this video, we learned about the many advantages of digital fluoroscopy over conventional fluoroscopy. There are a number of different configurations for digital fluoroscopic systems. Digital fluoroscopy, just as with conventional fluoroscopy, starts out with an X-ray generator and X-ray tube. From here, the X-ray beam is able to be collimated and hardened by the added filtration. It reaches the carbon fiber table that offers durable support for the patient without attenuating the beam significantly. Now the X-ray beam interacts with the patient's body tissues, attenuating the beam, and some of the X-ray photons are scattered. The remnant X-ray beam passes through the grid while the scattered photons are absorbed by the lead strips within the grid. The X-rays making it through the grid reach the image intensifier where the X-rays are converted to light and then onto the charged coupled device or CCD where the light is converted to an electronic signal and read pixel by pixel, and the image is made available on the monitor with little lag time. Some systems have replaced the image intensifier and CCD with dynamic flat panel detectors, which detect the radiation leaving the patient and convert it to an electronic signal, much like the direct digital X-ray image receptor. The dynamic images are then sent to the monitor to be displayed. The main advantage of digital fluoroscopic systems include the ability to image with less radiation and have high-quality images. Make sure to understand these advantages and the differences between the digital fluoroscopic systems. Hope you found this video helpful in understanding digital fluoroscopic equipment.